Now, this actually leads us to this domain in the soft OR known as the problem structuring methods. PSMs are defined as a broad group of problem-solving approaches and problem-handling approaches, problem structuring approaches that are there to assist in structuring problems rather than directly solving them. They should be participative, interactive, and they should allow for different perspectives, and they should be used also by a group of stakeholders. Now, if we see how they are applied in action, we basically can see that PSMs are applied to unstructured problems, and these unstructured problems then become structured, and they can either be solved by application of the traditional OR methods such as ST or AHP, so on and so forth, or sometimes they are solved by the consensus among the participants and their convergence towards a choice and their commitment to the implementation of that choice. Now, in ST, we already have a lot of problem structuring methods. Some have been developed within the field or have their origins from the field, like the magnetic hexagons or the cognitive maps. And some have been borrowed by ST modelers from other fields, mainly from soft OR field, like, for example, the rich pictures that are used by Checkland in the subsystem methodology. Some are the basic diagrammatic conventions that exist in the fields of management science, like the influence diagrams. Now, knowing that a variety of problem-solving methods used with ST, now the research question is, how can we compare the contribution and assess the performance of problem structuring methods in problem solving with ST? In other words, which one is a better fit for problem solving with ST? There's been limited evidence research on actually assessing the contribution of these different problem solving methods that exist in the community. Now we actually employ the classic management science research methodology, or the scientific way of management science research, in which we apply a theory to a research context to drive propositions, and then those propositions are translated to hypotheses with measurable constructs, and then those constructs are tested and validated. So in our case, the theory we apply to the system dynamics modeling process is the cognitive fit theory. We'll see what that is in a few minutes. And then we derive some propositions on how PSMs can lead to a problem-solving performance in the ST modeling process. And then, based on that propositions, we actually come up with the characteristics of a PSM that can improve problem-solving performance with system dynamics. And we actually put the test by doing user study and regional notation analysis. But this is a research in progress, so we are right now in the validation phase, and we've not yet come up with the results. So what I'll present today is actually to the end of the hypotheses, and I'll actually give an introduction to the validation phase of this research. Now, cognitive fit theory is a theory that can actually shed light on the cognitive processes that are employed by human beings while carrying out problem-solving tasks. So it actually basically it's about how human beings employ external problem representations and internal problem representations to form mental representation for the task solution. External problem representations are the knowledge and the structures that exist in the environment. For example, diagrams, graphs, or the beads of an abacus are all external problem representations. Internal problem representations are actually those knowledge structures that reside in the mind of the people, in the memory, in the working memory of the people. They apply these two to form a mental representation of the task solution, and then they actually carry out the problem-solving task. Now, if we can give an example of carrying out a task of multiplication of 365 by 12, well, the external representation for that task would be writing it down. So the very first thing that most of us do to carry out a multiplication task is to write it down. There are many people who can do it without writing it down, but most of us do it. So this writing the multiplication problem-solving task down is the external representation. Then this actually triggers the retrieval processes in our memory about, for example, the multiplication table. What is the multiplication result of 2 by 5? And then, for example, what is the numeric value of the symbol 2? And the mathematical arithmetic procedures for carrying out a multiplication task. So we use this external representation in order to retrieve those knowledge structures in our memory. Now, if instead of doing it this way, we use, for example, Roman numeric system or the Persian numbers, it would also be an external representation, but it will not help us in actually retrieving those knowledge structures in our working memory. So it will not lead to the activation of internal problem representation in our mind. It may match the problem-solving task, but it will not be useful for us. Now, if we look at the research context, which is ST model building, Richardson and Pugh actually outlined several steps for building ST models that start with problem situation identification, the model conceptualization, model construction, testing, sensitivity analysis, so on and so forth. But what's important here for us is just two main steps. The very first step in the modeling process is for the modeler to observe some aspect of reality known as the universe of discourse. The modeler then employs a set of conceptualizations to distinguish a number of entities within that universe of discourse and the relationships among them. Then, in the representation domain, the modeler goes on and builds the model using modeling constructs. So these constructs can be mapped onto the universe of discourse, the entities in the universe of discourse, by employing the conceptualization. So this is as simple as that. So in our world, in the ST modeling world, our conceptualizations are basically stocks and flows and the information objects. It means we look at the world and we see things like we see aspects of reality like stocks, flows, and information objects. So basically we can say that model building is divided into two subtasks: problem situation conceptualization subtask, and also ST model construction subtasks. And these two tasks interact with each other, and it's iterative basically.